Okay, welcome everyone to the Sec 4, Chemistry and Physics Head Start program. So for the next 1.5 hours, I'll be focusing on how do you ensure you get off to a blazing start in 2022, sharing many important things like revision tips, upcoming topics. I'll actually go through a physics and chem topic that you'll be doing next year. All right. So to start off, for those of you who are not familiar with me, I'm Daryl. Okay, I'm the chemistry and physics tutor for Overmark. I've been tutoring for a really, really long time now. Okay, next year will be my 8th year teaching. For myself, I do both group tuition as well as crash courses. So just last year alone, I hosted crash courses for over 200 kids, right, that went for O-level. So that was pretty exciting because it was a large group. But on a week-to-week basis, right now I'm tutoring around 10 to 12 classes of Sec 4s. So I think Sec 4s like yourself getting ready for O-levels. So that is more or less me lah. I only do upper Sec, right? And mainly Sec 4s. Okay, now down to the agenda for today. So let's talk about, we will be talking about what's coming in Sec 4, what are the hardest topics that you must look out for, okay, some revision strategy that you want to keep in mind. I'll actually be doing redox reaction and static electricity. But take note, I won't be going very in-depth. It's just to give you a taster, right? I know some of your schools might have done redox already, so you can just sit through it again as if it's a revision. And stay tuned to the end because I'll be covering a 1-year timeline, all right, up to O-level. I think this is the one you are most keen about. Like, what do you have to do at a certain point and what are the milestones that you have to hit, all right? Now, this is the overview for pure chem, all right? I hope that most of this looks familiar. You should have already finished this, and to a certain extent, this as well. The Sec 4 topics that you will be expected to learn would be under energetics as well as organic chem. I believe most of these topics you will not have learned it yet. Now, there are a few things I want to caveat here, right? So if you haven't learned QA, I think this is a chapter that you would want to keep in mind that it is very closely related to acid, bases, and salts. So when your school does teach QA, right, please go and study acid, bases, and salts to try to draw a relation between the chapters. I think this is really important. And with that, right, Sec 4 topics, this few that you have seen here, I think there are certain topics that are considered harder, right? Organic chem, do I consider it hard? I'll address it in just a moment, all right? For this chapter under periodicity and air, take note that these chapters here are usually more content heavy. So you'll want to spend a bit of time before your exam to run through the content, such as your reactivity series, your extraction of metals, and different trends in the group. But largely what you'll be expected to learn will be under these two columns. Okay, based on the way I have structured it, you can kind of see the approach towards chem here, like which topics you should study in totality. For example, like if you're learning kinetic particle theory, right, solid, liquid, gas state, you might as well revise it together with atomic structure and chem bonding. Try to think of these three topics as one big topic rather than separate topics. I think that will help make your revision a lot more precise because we know that whatever we learn in atomic structure is relevant and useful for chem bonding, right? And same thing, redox reaction, which is what we're going to do later, is highly related to electrolysis, same as acid, bases, salts, and QA. All right. So I already mentioned that when you're studying, right, try to group similar clusters of topics together. That will help you accelerate your revision progress. Okay. Some of the topics here you have already learned. I think you know what I mean. All right. But largely upcoming for energetics and for organic chem, try to look at them as one big chapter. All right. As usual, at any point, if you have questions, just stop me. If not, I want to keep going. All right. Now, what's actually coming your way in Sec 4? I think some of the big topics that you'll be learning would definitely include energy changes, exoendothermic, rate of reaction, redox, okay, being very strongly related to electrolysis, and the big one, which is worth around 20% of your paper, which is organic chem. Now, I know when you hear the word organic chem, you're like, wow, scary, yeah, like I'm not ready for organic chem. The good news is that organic chem, the moment you get it, right, is 3 marks. Literally. Organic chem is difficult to fully master. But once you actually master it, right, you would love it, especially if it comes out in the exam. With that being said, all right, for combined, it's a lot easier because there are lesser topics. If you're taking pure, there are some pretty abstract concepts that you have to master. Okay, there's this thing called isomers, probably one of the toughest concepts in all of chemistry at O level. Those are the kind that you would need to spend a bit more time on. But like I say, the moment you get organic chem, everything else is easy. All right. Now, wait. I go to this one first. So earlier we talked about what is difficult, right? I think briefly in the pre-session chat, right? Then I mentioned that, hey, probably the most difficult chapter would be electrolysis, right? So if you had time to browse through the chapter a little, you realize that electrolysis involves a lot of redox reaction. And more importantly, from an exam POV, right, electrolysis confirm come out. All right, you know your paper 2 is split into section A and section B, right? Section B is usually the place where it houses most of the difficult questions, right? The kind that if you want to score A1, you need to solve it, right? Okay. Section A, everybody can do one. That one, not to worry. Okay. Electrolysis has a very high probability of appearing in section B, purely because the way the chapter is constructed, it usually allows for it to bring in more extra stuff that challenges the boundaries of your knowledge. So when you're studying this chapter in electrolysis, don't gloss over it, don't assume, and don't underestimate it. Try your TYS, you will know what I mean. And even better, try other school prelim papers. Electrolysis is probably the single most challenging topic. The good and bad news is this. Last year, your seniors didn't have to do organic chem, right? So like 15 to 20% of the weightage is gone. But what that meant for them was that in the paper 2, usually there's an either or option, but they no longer had that option because they had to do the electrolysis question because organic chem was removed. For your year, the good news is that if electrolysis appear, you might be able to bypass it, right? Because it's an either or question, you can opt for the organic chem question. But overall, if there's a chapter I always spend a lot of time with my own students working on is electrolysis because of how important it is in the exam. Okay, organic chem itself, I want you to take a look at this next page, right? This is what I call the spider web for organic chem. You realize that everything is related to something else, right? Like you'll be learning this chapter called alkenes, alcohol, carboxylic acid. But you notice they can morph from one form to another, and you look at the different reactions as well as their conditions. So this is what organic chem is about. It's about how do I change from one form to another? How can this and that come together to form a new product, right? So in organic chem, the focus is truly on making sure that you're comfortable with looking at the big picture. Do not study organic chem chapter by chapter. That is like nonsense, all right? Please don't do that. The trick is to study like what you see here on the mind map. Good news, this mind map is available on the website. You want to download it, go for it, all right? It's available. But when you're studying organic chem, please do that for me, okay? Please do not study it chapter by chapter. You're wasting your time, all right? So I hope I addressed those questions about organic chem. Largely, it's about memorizing your reactions and how they interconvert from one form to another. Okay, so this is for chem. Next, I move on to physics. All right, these are the topics that you see here. Your school should have covered Newton mechanics, thermal physics, and a good portion of waves, at least light waves and light, I feel, if your school is decently fast, right? Sec 4 topics would usually entail electricity as well as your magnetism topics, all right? Now, take note that for electricity, DC circuits is usually a bit more tricky because there are different ways to configure your circuit. If there's a chapter that I want you to do more practice on, it will be DC circuits. So DC circuits, there's really a lot of question types, like honestly, a lot more than current electricity and practical electricity. So pay special attention to DC circuits. Especially for my pure physics students, you'll be learning things like potential divider and your thermistor as well as LDR. Those kind of questions usually kill students, which means in exam, you won't be able to do it. Those are the questions you need to spend more time on, all right? I think earlier there was a question on what is the most difficult topic in physics, right? Trust me, okay? It's the last chapter, electromagnetic induction. The bad news is that your seniors didn't have to do it because common last topic was removed. But I have a feeling for your year, right, there won't be a removal of common last topic already. Okay, unless the Omicron like jalat, then your home-based learning and whatever lah. But I feel like with how the COVID situation is panning out, you need to brace yourself for this chapter. Okay, so this is for pure physics. In terms of the hardest topics, I would definitely say DC circuits, because you need to be comfortable with various circuit setups. It can get very complicated, which is why for myself, with my own students, I always do a lot of prelim related questions for DC circuits. Meanwhile, for electromagnetism, it has a high chance of appearing in section B, especially on the motor and application side of things. So this is the next chapter that if you are serious about getting your A1, this is the chapter you will want to pay a lot of attention to. And it's usually quite difficult to understand. So this is the chapter, if you're a bit unsure, right, you go and ask your teacher early, right, to make sure that you don't make any like major misconceptions early on. Okay, maybe I pause here first. Any questions about the topics and any more things you all like to ask about those topics? Okay, now you're scared on. Okay, won't die lah. Okay, but just need to be a little more on the ball. Okay, if you're sleeping in Sec 3, please wake up in Sec 4 because the topics are a lot harder. Okay, for obvious reasons. Okay, so to give you a brief idea, right, this is how a question for DC circuit can look like, right? I set this question myself to torture my students, not torture, to help them learn better, right? So if you can see here, a circuit can be as complicated as having 3 different components with the ammeter and voltmeter at different positions, with different resistance. By O level, you need to be able to solve this question, right? So you can all the way from part A to part E, then really the values are all very heavy on calculation. So when you eventually reach DC circuits, get your foundation right first, then move on to think about what are the question variants, right? Which means how can this chapter be set, right? There are a lot of variations here. So I would say that if it's DC circuits, pay more attention, especially when your school is teaching this chapter. Okay, and practice. Okay, now you are only 1 year away from your O level, which is honestly, it feels quite far away, but actually you have less than a year by now, right? Realistically, 10 to 11 months left, not a lot of time. So I think what I'm hoping to share here is how best do you set yourself up for success, all right? And the first strategy that I think always works, right, is that you need to check whether you know your content. Okay, what this means is that after you learn a new topic, like later when you learn redox or static electricity, I want you to try and recap the knowledge and test yourself, which means after you finish studying, close the book, go for a walk, okay, use a little bit of TikTok, but come back to it later and check, what do I remember from the chapter, right? Test yourself. If you can, right, if you have a friend with you, right, see if you're able to explain what this chapter is about to your friend. If you're able to do so, that's when you know the content portion is secured. I know my shit. That is what strategy 1 is about. But take note, learning the content is only 50% of the battle won. After you learn your content, you need to learn how the questions are being set in exams, right? Because the content is just like information, right? You have a dictionary review, that is content. But writing an essay is a different skill, right? In the exam, DC circuits, you might know all your formulas, but do you know how questions will be set and what kind of questions are more common, right? So only through the practice, then you can affirm that knowledge that you know in terms of the application portion, right? Like, okay, DC circuits, they will test me like that. I need to use concept 1, concept 2, concept 3. So never ever underestimate your practice. All right. This is not a secret. I always share with anybody that asks me, right? How many times do they have to do their TOS? For my own students that I teach, they do it 3 times. Okay. If you need a gauge, that you can use that as your benchmark. But if you haven't touched your topical TOS at all, you might want to start thinking about doing it now. All right. So TOS is super important because you need to learn to be familiar with how Cambridge sets questions. Right? It's like it's playing a game. Exam is a game. Don't think of it too hard, right? You know the game, you need to know the rules of the game, what kind of games are coming out, right? If you draw reference to Squid Game, it's like, if you know that tug of war is going to come out, obviously you go and train on your strength. So it's like, if you know electrolysis or electromagnetism questions will come out in section D, you might as well prepare for it. Because honestly, right, at O level, there's a certain answering template. And once you figure out what are the question types that come out and what kind of question keywords goes into it, actually it's not that difficult to do well. But make sure if you're doing your TOS, don't just spend time to review and to do your corrections. Corrections is so much more important than the doing. Because corrections means whatever you don't know, you learn it. Whatever you already know, you already know. You don't have to worry about that, but worry more about the things that you do not know. Okay, so think of it from a 50-50 perspective. Learn your content and learn to apply that content and solve questions. Don't overdo either one side without the other. If you just learn content, you're not going to do well in the exam because you did not do the practice, right? But if you just practice without knowing your content, that's like shooting yourself in the foot. It's even worse, all right? Always content first, followed by practice. Topical TOS means topical 10-year series. 10-year series is a compilation of the questions from the past 10 years that were tested at O-level. So it's like the trick. I mean, if you're going for O-level exam, you might as well learn how they set the questions. Okay. So make sure you go and purchase a copy and start doing. That is my most sincere advice for you if you're planning to do well. Okay. Which school prelim papers are the hardest because you want to practice? I don't want to stereotype certain schools, but in general, I really think it differs from school to school. But if you want to gauge which school is the hardest, you can look at the cutoff point. I think that's a good way to approach it. So the cutoff point for the school is high. They usually set quite difficult papers. Difficult doesn't mean best papers to practice. You want to practice a range of difficulty. That's usually the best. Okay. Where can you find other school prelim papers? I think there's a lot online. For myself, I work with a supplier, so my students have access to the latest prelim papers. But I can find one. You just need to go and find it. All right, you can go and buy or online. There's a lot. You can look for more. All right. Now, I think these are some important tips that I like to share before I jump into the content segment for today. You might feel like I'm nagging you, but really these are super important. Remember earlier I mentioned electrolysis is probably the most difficult chapter in chemistry, right? I need you to know that in order to learn this chapter on electrolysis well, you need to get your foundational chapter right. And that means getting redox reaction right. So when you learn redox reaction, right, I don't want you to just like think of it as easy oxidation reduction, who don't know. I want you to understand the level of mastery you need for this chapter is not just about this chapter. It's related to other chapters as well. Same for physics. If you don't get your current electricity right, you will struggle for DC circuits, right? And if you don't get your electromagnetism right, you're going to struggle for electromagnetic induction. So when you're learning one chapter, right, don't underestimate it. And most importantly, if you have doubts, please learn to clarify. I think it's a very underrated skill for students, and that skill is asking questions and asking the right questions. So I know if you don't have the time to, or you're a bit shy kind, right? After lesson, go up to your teacher and check, all right? Or maybe book a consultation with your teacher after school to see if they can clarify some of your doubts. The reason why I see a lot of students struggle, right, for those that are failing and stuff, is because they allowed their doubts to accumulate. So when they don't understand, they don't bother to find out more. And then they just accumulate so much question mark, until everything starts to not make sense. So if there's anything I urge you to do is to clarify doubts early, especially if the chapters are going to be built upon one another, right? If you don't get the first two chapters in organic chem, you have to go and do something about it already. Don't wait. Because if you get stuck at the first two chapters, the next three, no matter how hard you study, they won't make sense. All right. And I know it's all in our DNA to be very last minute, right? So because it's exciting, right? You get like the adrenaline rush. Wow, the day before I need to study until 3 a.m. for my test, then show. No, but try to avoid that, especially in Sec 4. All right. So Sec 3 and Sec 4, I just want you to set the expectation right. That it's not a year that you can play around anymore, because O levels at the end of the year. Sec 3, if you play, you don't do much. I think still low-key acceptable because you still promote to Sec 4 and you're fine, right? End of year, you fail, you laugh about it with your friends, you all cry together, but hey, life goes on. But at Sec 4, if you screw up your O level, that's it. You get a second chance, but I don't think you want to spend another year preparing for O level. You want to move on with the next phase in your life already. So last minute, especially last minute for O level, trust me, it doesn't really work. Okay. Some students manage to pull through, but I think it's a very, very small group. So what I need you to focus on is how can you change your mindset towards your revision? Try to think of it more as a marathon. How can you spend 2 hours every day rather than 10 hours the day before, right? It's about distribution and time management there. So this is a skill you need to pick up soon. If not, you're gonna drown in Sec 4. Okay, not to scare you, but it's just a very real advice coming from a student myself and watching so many of my other students, those that really do very well and those that are struggling. Usually it's about the time management, right? Whether they are consistent or they are last minute, okay? And whether they dare to ask questions, okay? So I think these are some things you want to get your head around. And if you get it right, trust me, it's gonna be a lot more smooth sailing. Okay, I give you a choice. Do you want me to do chem or physics first? I'll do the one with more votes. Preference? Megan, why are you here? Wow, a bit mixed, yeah. Chinese, sorry, bro, I don't do Chinese, man. Chem, physics, chem, physics, chem. Physics, chem. Okay, lah. Gareth, write the physics with the please z. Okay, we do physics first, okay? Then, those that only want to do chem, right, y'all come back in 20 minutes. Anyway, for those that are planning to come back for chem, right, it's good because I'm gonna do a timeline thing at the end with Q&A. So try to stay till the end. Then give me 20 minutes to go through physics. I'll spend another 20 minutes with chem. Okay, so those that want to do chem, y'all go chill first. In 20 minutes, you'll come back. I think that would be a good estimate. So 5:50, right? Then we'll start doing chem. All right, let's go for physics first then. Let's go. Actually, guys, this week is supposed to be my break, I cancel all my group tuition classes. I'm supposed to chill. What am I doing here with you guys? Bunch of overly zealous Sec 4s wanting to do well for O-level. Okay, quite fun. But y'all entertain me a bit, ask me some questions. If not, I'll be very bored. Okay, the topic that we're doing today is static electricity. How many of your schools have done it already? Maybe you can give me a thumbs up. Quite rare though, I would say, for your schools to have done it, unless your school is like freaking fast. Oh, Arjuna, your school done it already? Insane. Oh, self-learning lah. Okay, if you're self-learning, then whatever. Self-learning is damn useless. Then basically, you don't learn anything. You just go through the content. Okay, this chapter, right? I'll tell you my secret. This chapter, there's only 2 things you need to know. Okay, I'll tell you what the 2 things straight up. Listen. Number 1, your positive charge don't move. That's all. That's the first one. So remember, when you go back to your school or your school is teaching, just remember to remind yourself that the positive charge never, ever, ever moves. Okay? If anything moves, is the negative charge, aka the electron. The number 2 thing that you need to learn is that unlike attracts. Okay? Like charges repel. That's all. If you have your school notes beside you, you just write these 2 mantra. You say, Daryl says, Daryl, law of static. Okay? Even when I teach my own student, right, this is the only 2 things I mentioned. Positive charge don't move, unlike charges attract, like charges repel. That's all you need. Okay, why do I say that? Let's move on. You need to copy? Give you maybe 10 seconds to copy. Learn to write fast, guys. Okay, let's talk about this chapter. So the first thing, remember, is unlike charges attract, like charges repel. Okay, for those of you who are wondering what this is just the soft copy of the curated notes. Okay, so I'm just going to static electricity right now. So I'm using this chapter, the notes to teach y'all. Okay, so you need to know that unlike charges attract and like charges repel, I think this one is straightforward enough. The units you do know. All right. Now let's take a look at this situation first. All right. When you have a neutral object with a charged object, what happened here? Can you see? Unlike charges attract. Okay. And when these 2 attract and they eventually touch, what happened was that the negative charge moved in. All right. Then what happened is that when the negative charge moved in, now there is positive charge on the big one and the positive charge on the small one. Then what happens? Like charges repel. So they repel each other. So the logic of this chapter can be governed by these 2 laws. the fact that the positive charge don't move, right? Remember the electron moving from the left side to the right side, and the moment they are both similar charges, they repel. So that's all you need to know. Okay, now that's obvious. Of course, we need to go more in depth. It's so easy, right? It won't be that easy. Okay, now there are two things that you need to learn to charge. The first is an insulator, and the second is learning how to charge your conductors. To charge an insulator, it is pretty straightforward. Okay, the only way to do it is via friction. Because it's an insulator, the electrons are not able to move freely. All right. So what will happen here is that when you use friction, for example, if you take a cloth and you rub it against a plastic rod, what will happen is that the electrons would move. So in this case, let's do a quick quiz. Did the electron move in or out of the positive charge rod? Can you type in the chat? Did the electrons move in or out of the positive charge rod? It moved out. Wow, I see many answers. I scared already. Guys, what? Out. Okay, tell you why. The uncharged plastic rod was neutral. The uncharged cloth is neutral as well. Neutral means I got equal amount of plus and minus. When I rub it with friction, the friction caused the negative charge to move to the cloth. So what happened? Now my rod that is remaining is positively charged. My cloth received the electron, now it's negatively charged. Is it true that only the negative charge moved here? Yes. Okay, so the movement of electron by rubbing here in this specific instance is that the electron moved out from the rod to the cloth. Okay, you'll get how it works. So it's about transfer of electrons mainly. All right, I don't want to go too in depth. This is just more of an overview kind of thing and letting you know what to look out for. Now, charging of conductors, fortunately or unfortunately, there are a total of 3 methods. The bad news is that you need to know all 3. The good news is that they all are quite logical, which means you do not actually have to memorize them. Now, I'm just going to go through one, which is in this case, induction. All right, method 1. Take a look. When I put 2 neutral spheres side by side in contact, all right, and then I put a negative rod here, what happened? All right. Did the positive charge get attracted to the left-hand side? No. The positive charges did not get attracted to the left-hand side. I repeat, the positive charge did not move. Remember the 2 rules? Positive charge cannot move. So when I put a negative rod there, it's not that I attracted the positive because positive is stuck. They cannot move. So what has happened is this. Read. Since light charges repel, electrons in sphere A would travel away to sphere B. So the electron that was originally here ran away because light charges repel. Now, sphere A has more positive charges. That's why sphere A looks as if it's positively charged. So if there's, remember the 2 rules we started at the start, right? Positive charge don't move. So when I bring in a negative rod, it's more of my negative running away. After I cause this movement of charges, I then split up my sphere A and sphere B. Okay, so you would separate both the spheres. Now they can no longer move, right? Because they need to be in contact before the electric charges can move across. Now they are separate. I remove my rod. Sphere A is permanently positively charged and sphere B is permanently negatively charged. That's all. You'll get how it works? So I know it's, I mean, of course, this is the first time you're learning. It doesn't sound that intuitive, right? But if there's anything I want you to learn here is the 2 most commonly made mistakes, okay, is that students assume that the positive charge gets attracted. Okay, as long as you remember my first rule that positive charge don't move, you'll be safe. And the second one, unlike charges attract, light charges repel. For this case, you'll use light charges repel to justify your answer. Okay. Yes. Sir, wow, I become sir, yeah. Please, I'm not sir. I'm just Daryl, guys. It's true. Okay, for charging the insulator, Why can't the electrons move from the cloth to the rod instead? Let's go back up. So the question, why can't electrons move from cloth to rod instead? Can or cannot? It's possible. But for this specific scenario, as electrons are transferred, this one, the transfer is quite obviously from your rod to your cloth. If my electrons move from my cloth to my rod, then my cloth would be positively charged. Because my electrons move away, then my cloth remaining behind is positively charged. Then the charge you see here on the diagram will make sense already. Okay, so it's about where the electrons move to, leaving behind the plus or adding on to more negative charge. So this is what the chapter is about. Okay, of course, there's other induction methods. The good news is that they obey the two laws that we have just discussed. So I do not need you all to be too worried about this because you will learn this in detail. But most importantly is to keep those two tips that I shared in mind. And of course, if you can charge means you can also discharge, right? So learning the different ways to discharge is just as important. This one will be tested, but in smaller context as compared to the charging processes. Okay, so the rest you can go and read through. Your school probably slightly different variation, but for myself, I usually teach 3 methods. Okay, next, let's move on to the drawing portion. So this chapter will require a bit of drawing, specifically the drawing of electric field lines. Okay, give you a moment to digest this content first. Okay, Mr. QQQ, the reason why the positive charge is at the left side, according to the example we discussed, is because the electrons left. So when the electrons leave, right, there is the positive charge that was left behind. So that's why there was a plus on the left side. So the plus indeed did not move. So each plus came with a minus. It's like boy, girl, right? They want couple, right? Then you bring in the negative rod. Then the negative rod repel all the minus to the right side. So all the girlfriend run away, leaving behind the boyfriend, the positive charge there. Something like that, if you get what I mean. So it's about repelling the electrons away, leaving behind a positive charge. I hope I answered your question. Okay, for this chapter with electric field lines, some good tip that I want you all to learn is that when you're drawing, the lines should never cross each other. It's always from plus to minus, and the distance between the line represents the strength of the electric field. A general rule of thumb is that how many lines do you need to draw? I'll say per charge is good to draw 6 to 7. That is my own standard, right? Your school teach you something different, you follow them lah. But for me, I always tell my own students 6 to 7 is good. Okay, drawing of electric field lines would be important because you have different variations, right? There's a lot more other than this few that you see here. Okay, of course, it comes with a bit more practice. You will see those examples. Okay, what is next for this chapter is a lot of content related stuff, right? So you need to learn some electrostatic hazard, such as formation of lightning, okay, and build out of charges due to friction. So this can be quite scary because if there's a sudden discharge, right, you can ignite highly flammable load, right? So that's the reason why there are always metal chains attached to the back of the lorry, right, or the trucks, so that they are allowed to discharge. The one that's tested a lot more is the formation of lightning. Okay, so formation of lightning is actually just a discharge of electrons. So the reason why we always put the lightning rod at the top of the building, right, is because we want the lightning to be absorbed by the lightning rod and it doesn't hit the ground. So in Singapore, it's generally quite safe with lightning because we got a lot of tall buildings, right? So if anything, the lightning strike, right, they usually strike the lightning rod on top of the building, and that lightning rod will discharge everything. So you're safe. But if you're in an open field, right, and there's no tall tree or tall building, and you are in open space, right, the lightning can strike anyway. And if you sway, you're standing at the exact spot, the lightning will strike you. Technically, I don't think you'll die, but you'll be very, very badly damaged. So that's quite scary. So normally during lightning, that's why your school would have the lightning alert, right? And then you cannot play soccer already, right? Or frisbee or whatever. Because when you're outdoor now, you're prone to getting struck by lightning. So during lightning cases, it's always good to stay indoors under a shelter. Is it good to stay under a tree? Not the best choice, okay? Because the lightning can discharge to the tree, and you're underneath the tree, you might gonna electric shock, okay? Definitely not ideal for anybody. Unless you wanna try it, I still don't think you should do it. Okay, now, in terms of application, all three, photocopier, spray paint, as well as your precipitator, all three have an equal likelihood of coming out with a slight preference for photocopier. So if you go and take a look at your O-level, photocopier came out twice in the last 10 years, all right? It involves the understanding of how static electricity affects these appliances, like how a photocopier works, right? You know, like you need to change your toner, right, for your photocopier. The toner is required for your printer and stuff because it works via charges. So this one a little bit too tedious and a bit lazy to go through everything. But what I'm saying is simple. You need to study this in conjunction and understanding how static electricity works within a photocopier. Okay, I think a lot of this you can find it in the free notes too. This is just a bit more detailed because it's the curated notes. But at the end of the day, you just need to study all three and make sure you're confident. Should a question come out, you're able to explain how did static electricity allow for these appliances to work. So this chapter is as simple as understanding charges, right? How the electrons and proton function. Remember earlier we did the charging of a conductor, right? So that's one, drawing electric field lines and knowing your applications of electrostatic. This is not a big chapter, nor should it be a scary chapter. But for some reason, a lot of students struggle with this chapter because of how complex it can look. But if you spend a bit of time to dive through the details, right, it's actually quite okay. Okay, so some of the commonly tested questions are usually found at the back of the chapter. For those of you who already have your curated notes, you can take a look. So for example, you take a look at this situation, right? Can you see W and X, they are attracted? So if this is minus, this has to be plus. And if this is plus and there's repulsion, this has to be plus. And Y and Z is also repulsion, so plus. Therefore, answer it's positive, 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 something like that, right? So it's about as simple as unlike charges attract, like charges repel. Okay, and then we can take a look at commonly tested question 2 as well. There's one keyword. If the spheres do not touch, there will not be a movement of electrons or negative charge. So conductors need to be in contact in order for the movement of charges to occur. So if sphere A and sphere B do not touch each other, sphere B would remain neutral, regardless of what nonsense you're doing with sphere A. As long as they don't touch, there's no transfer of charges. Okay, so that's more or less what you need to know about the chapter. I deliberately went very brief because today is not the day for a deep dive. It's just to give you an overview of what's to come. Obviously, when you learn the chapter itself, I want you to spend time to read through every single line and to look at the details here. But for now, it's just giving you an overview of what's to come for this chapter. Okay, maybe I can spend the next minute or two to clarify any questions because I think some of you are quite confused with how the charges work. So if you got questions, now's the best time to ask. Okay. So I think I have a question from I. Why aren't the positive charge distributed evenly throughout the sphere? I think you're mentioning this question, right? So why is the positive charge all on the left-hand side? The reasoning is simple, all right? It's because there's a negative rod here, right? So the negative rod here causes all the electrons to repel onto this side, and the positive charges here are indeed strongly attracted to the minus. So the redistribution of charge only occurs after you remove your charge rod. Then your charge will distribute evenly. And even then, it's not that the positive charge moves. It's the redistribution of the negative charge allowing the charge distribution to be constant. Does it mean if they are attracted, they move? No, the positive charge never ever moves. All right? So the reason why the left-hand side here is positive is because the electrons move away, leaving behind the positive charge. That is why you see an uneven charge distribution. So like I said, remember the two rules I said at the start of the chapter? The positive charge never ever moves. The moment you write that, you're factually incorrect. So no matter what you do, right, it's always the electrons that are moving. You need to wrap your head around that idea. Okay, I know it's very easy to say unlike charges attract. We put a minus there, then the positive charge get attracted there. But positive charge cannot move, so it doesn't get attracted there, right? Even though the positive charge are indeed attracted to the negative charge, but the only reason why the charge distribution is as such is because of the movement of the electrons. Does being negative mean that a sphere has only negative charge or more negative than positive? It will be the latter. So if something is negatively charged, it means that there is more negative than positive charges. Negative charges do refer to electrons, even though we prefer to reserve the use of the word electrons more for chemistry. So if you're doing physics, I tend to stick with negative charges. But as you can see here, I also wrote electrons. It's the same thing, basically. No, sphere A has both positive and negative charge, but there is more positive charge than negative charge, which is why it's positively charged. It's a bit like proton-neutron, right? If I have more electron than proton, I'm negatively charged, but I still have proton. Positive and negative charge here is just proton-neutron. That's all. But good questions. You're asking the right question. The kind of questions that I'm expecting from students that are actually thinking of the chapter. Okay, but it goes back down to the fact that I said, positive charge don't move. Yes, the higher the number of that charge, that is your overall charge. Okay, for commonly tested question 2, why is sphere 2 still neutral? Why is there no transfer of negative charge? It's because of the keyword. When we move sphere B nearer to sphere A, while it's nearer and there will be an induced charge, the charges do not transfer because the spheres didn't actually physically touch. They need to be in contact for the charges to move around. So if the spheres do not touch, sphere B would remain neutral. Jermaine, is that okay? Does that make sense? Because they didn't touch. If they touch, confirm there will be a movement of electrons already. Then we need to study which side is plus, which side is minus. Okay. Arjuna, why the positive charges can't move? If you want to take a more chemistry approach, the protons are stuck in the nucleus. You can't move out of the nucleus or your metal lattice. But the electrons are free-moving electrons, so they can easily transfer. Okay, so the next question, isn't the rod not touching the sphere? It's definitely not touching. So did the rod transfer electrons to the sphere? It did not. All it did was that originally it was plus minus plus minus. Remember the couple? But then what happened is that it forced the electrons to repel to the right side. So when you bring in a negatively charged rod, you get a plus plus minus minus. Not because the plus is attracted, but because the minus was repelled to the right side. But is there any transfer of charges? No. It's just causing an induction. Induction means uneven distribution of charge. Like one side is more plus, one side is more minus. This is how I induce a charge. Cannot. Do you get the aha moment? So by bringing in a negative rod, I can play around with the charge distribution in A. And if B really touches A, right, then the negative goes to the B. Then you separate them. Then now one is plus, one is minus. By all point in time, the rod did not touch the sphere. Okay, right? So this chapter not that hard. You stick with my 2 rules, you'll be fine. Okay. As long as you know that the positive charge don't move. Okay. So when your school actually teach this chapter, right? I don't know whether your teacher will actually emphasize on this. But for me, it's very obvious. This is where a lot of students go wrong. I think if you didn't attend today's session, you might just say positive get attracted to the left side. Then you blur, then you, why is it wrong? You don't even know, right? But here we establish that that is the key thing to look out for. I think very important. Yes, the charge can be induced and yet the overall charge, net charge is still 0, as long as plus and minus is equal. Yes, the diagram I just drew is the initial diagram of a neutral sphere. No, initial diagram is so if I zoom in a bit, okay like you're asking good questions give your credit when credit is due. Wait, I draw a bit. If it's a normal charge, right, what happens is this. By right, if you say, if it's blank, right, blank means there is plus, minus, plus, minus, plus, minus, plus, minus. But we don't write it out because it's equal, ma. But when you bring in this negative rod, the minus go over to this side. So the left-hand side is only plus. The right-hand side has plus, minus, minus. So instead of writing plus, minus, minus, I just write minus, minus, like minus and minus. You get it? Because plus, minus, minus, the net charge is minus. Oh, so I just write a minus there. That's how it works. What if you remove the sphere B before the negative charge gets transferred? The charge transfer is very fast. It's more of whether it touched or did not touch. If it did not touch, cannot transfer. Electron cannot fly through the air, right? So only if the conductors touch, then there can be a movement of charges. Yes, there will be charges on the right side, but there's more negative charge than positive charge. That's why the overall charge on the right side is negative. It's like cation and ion already. If I give away an electron, I'm a cation. Ma. If I receive an electron, I'm an anion. That's why on the right side is a negative charge. Okay. Energy conversion question for static electricity, very unlikely. Static electricity will be linked to current electricity because in the next chapter in current electricity, you see that you learn convectional current and electron flow. This question is commonly tested in conjunction with lightning. Can see electron flow, so your current should be traveling in the opposite direction, something like that. Okay, but next time then you'll worry lah. Okay. If there are no further questions right now, the time is 5:55, 5:53-ish. I'll start doing the chem at 6 o'clock. Okay, because I need to go to the toilet. I drink too much water. All right. The focus is more on giving you a brief overview. Same thing, what to look out for. Where are the mistakes that typically other people like yourself would make, right? And how to avoid them. The content part, give yourself a bit of time to get used to it. I only have 15 minutes. I tell you the important stuff. Okay. So the first thing I need you to know about this chapter is that between oxidation and reduction, there are a lot of ways, right, to figure out whether something oxidized or whether something reduced, right? So oxidation is defined by a number of criteria. If you gain oxygen, you oxidize. You lose hydrogen, you oxidize. You lose electron, you also oxidize. You increase oxidation state, you also oxidize. Oxidation state is just a charge, right? For example, Fe2 plus go to Fe3 plus. This is oxidation already because my charge increased. That's oxidation state. Same thing for reduction. These are your key ones. All right. But if there's one thing I want you to learn from this lesson is this. Change in oxidation state is the true test for whether a substance has been oxidized or reduced. Okay. Why do I say this? I think it's important for you to know that gain of oxygen, loss of hydrogen, and loss of electron, they all help to increase the oxidation state. Okay, loss of oxygen, gain of hydrogen, gain of electrons, they all help contribute to decrease in oxidation state. So it's like the only one that truly matters, the one that I can confirm whether it oxidized or not, right, is usually by looking at the oxidation state. So oxidation state is usually the best way to check if something has been oxidized. I give you a simple example. Okay, let's say I have Na. It reacts with water to form NaOH. Did Na oxidize or reduce? Type in the chat. Okay, did Na oxidize or reduce? Come, try. Okay, I tell you why it's confusing. Do you see, is there gain of oxygen? Got right. You see the Na before that was forever alone, right? Now it gained an oxygen. But did it gain a hydrogen? Got gain hydrogen also, right? So the question is, I gain oxygen, I also gain hydrogen. So is it oxidation or reduction? Like, what the hell, right? It's not redox, by the way. Okay. The answer is that it's oxidation. Okay, but how do we know, right? But it gained hydrogen, right? So how do I know whether oxidized or reduced? This is what I mean by the true test is to check the oxidation state. Sodium metal itself, does it have a charge? No. So the charge here is 0. NaOH. NaOH. OH is minus charge, right? We learn it in acid bases. So Na's charge is +1. So the oxidation state went from 0 to +1. And what does that mean? It means oxidation. So SY, you're right. All right. Can see? So yes, I can look at oxygen, I can look at hydrogen, I can look at electrons. Cool. Those give me a clue whether it got oxidized or reduced. But when it gets confusing, the only way to check for it, okay, is to check using the oxidation state. You're clear what this point of emphasis is? Okay, so I'm not going to go through the rest of the stuff, right? You can go through it yourself. Your school probably have a different example, but whatever, this is what I like to use, right? Here it takes a look at why it got oxidized, why it got reduced. But most importantly, like I say, the only one I truly care about to confirm its oxidation state, to confirm whether oxidized or reduced, is to use the oxidation state. Just keep that in mind when you're learning the chapter in school. It will go a long way. Okay, in chemical bonding, after that, you went on to more concept. You would probably learn chemical equations. And you probably learn this thing called an ionic equation as well. I need you to know that the final version of it is the ionic half equation. So here we got chemical equation. Remove spectator ion, you get an ionic equation. A half ionic equation means I'm breaking this ionic equation into two halves to showcase oxidation and to showcase reduction. In ionic half equations, we always show the electrons. That's the difference. Okay? And the importance of this is that ionic half equation is needed in electrolysis. I cannot spell electrolysis, whatever. I can spell, I just cannot spell now. Okay? So I give you a quick teaser. If you go to electrolysis, can you see? This is a what? Can you see the electron? Electron, right? Once again, electron. These are all called ionic half equations. And obviously, when will you learn ionic half equations? Definitely in redox reaction. So my tip for you is when you're learning redox, take it seriously. Learn everything that you know about this chapter. Because later on, when you do electrolysis, the hardest topic, right? You will want to be amply prepared. You don't want to have to think about, oh, what's oxidation, what's reduction again. By the time you hit electrolysis, it should come intuitively what oxidation and reduction is. Okay, your school confirm teach redox first before electrolysis. If they don't, right, they teach electrolysis first, right? I don't know what to say. Okay, it's impossible. All right. So that's what you need to know. Now, for oxidizing and reducing agent, this is the other portion that you will need to learn. This one, just think about it logically. If I'm an oxidizing agent, what am I going to do? My job as an oxidizing agent is to cause another substance to get oxidized. I'm an oxidizing agent. I'm going to go oxidize other people. So I will help other people oxidize. In the meantime, I would undergo reduction. There's exactly two oxidizing agents that you need to learn, as well as their color changes. Okay, oxidation state here, important, but I'll let your teacher teach it. Okay, if not, I teach everything, your teacher don't need to do anything already, right? Okay, so I'm gonna let your teacher teach, okay? But most importantly, can you see that for the oxidizing agent themselves, the oxidation state decreased +7 to +2, +6 to +3, right? Color change, purple colorless, orange to green, right? So an oxidizing agent will cause another substance to get oxidized, while it itself will undergo reduction. On the other hand, a reducing agent will do just the opposite, okay? A reducing agent will cause another substance to get reduced. Meanwhile, they themselves will undergo oxidation. All right. So here we see that iodine actually oxidized from -1 to 0. Color change is colorless to brown. So this is the logic behind it, right? Oxidizing, reducing agent. What's their mission, right? If I'm James Bond, I'm an agent, I'm a reducing agent. My job is to go and reduce somebody else. In the meantime, I would sacrifice myself. I will undergo oxidation. So that's how it works. Normally, when you do an oxidation reduction reaction, it is when both occur, it's called a redox reaction. That's why this chapter is known as redox reaction. So this chapter is two things: oxidation, reduction. That's all. Okay, identifying and learning how to calculate and knowing what your oxidizing and reducing agent does. Okay, of course there's more lah. Okay, but all this I feel is a bit too much details for now, right? What we are looking for today is an overview, right? So first thing to recap, know your conditions for oxidation and reduction, but acknowledge that the best way to test for this is to check for oxidation state. Next, learn your ionic half equations carefully because you'll need it in electrolysis. Lastly, get familiar with your three main oxidizing and reducing agent. Two oxidizing, one reducing. All right, go and learn their color changes as well. That is what will be tested. Okay. Fortunately or unfortunately, redox reaction is also highly related to many other chapters. Okay, such as metals. Okay, displacement reactions are redox reactions as well. So you cannot take this chapter lightly because it's a little bit like Mo because it involves calculations, but it has applications across multiple chapters. I just give you all one for fun. All right, let's do this together. You all learn metals already? Yes? No? Don't know? We just do one. We pay attention to this equation. I give you all one question only. Identify the reducing agent. Metal is the reactivity series. Then the blast furnace is under extraction of metal. Okay. The question is identify the reducing agent. Okay, I start to see the answer in the chat. Okay, can you all type out why carbon monoxide is the reducing agent? Explain. 2 marks. So explain why carbon monoxide is the reducing agent here. Okay, I see the correct answer. At the same time, it's also the wrong answer. Okay, I'm going to be very delicate about this. Y'all listen carefully. It is true that carbon monoxide is indeed the reducing agent. So when you're identified correctly. Now, how did we identify it? We try to look for something that oxidizes, right? We know a reducing agent, his job is to reduce somebody, but he himself will oxidize. So when you saw that carbon monoxide turn to carbon dioxide, can you see it gain an oxygen? Gain of oxygen is what? Gain of oxygen is oxidation, right? So I confirm that CO oxidized to CO2. This confirms that CO is my reducing agent, right? Because I reduce somebody else, I myself get oxidized. But if I'm required to explain why is it a reducing agent, I do not talk about the fact that it got oxidized. I talk about the fact that it caused Fe2O3 to reduce to Fe. I'm going to draw this in another color. I repeat again. In order to justify why it was a reducing agent, I cannot talk about CO. I will instead talk about what it caused to be reduced. It caused Fe2O3 to reduce to Fe, right? Can you see loss of oxygen, right? Losing oxygen is reduction. So there are two parts to this. How do we easily identify a reducing agent? We check for the one that has oxidized. That speeds up the process. I know my reducing agent. But if I'm required to explain why is it a reducing agent, I don't talk about it itself. I talk about its mission. Its mission to reduce Fe2O3 to Fe. You all get the slight difference? One way is quickly identifying the answer. The other way is how do you explain in an exam? Your answering technique here. So there's a slight nuance there. It's very slight difference, but you're on the right track. Okay, so I don't explain that I'm a reducing agent because I gain oxygen. I explain it by saying that I caused something else to reduce. And I identify from which compound actually got reduced. Okay, so you'll learn a lot more about this kind of things. I hope your teacher will teach you this in terms of the answering technique, how precise it has to be. But I think this is something that, if anything, it will be good to learn. So oxidizing reducing agent, you justify it is as such because it caused something else to oxidize or it caused something else to reduce. So going back to what we shared at the start. Okay, open to questions. If not, I'll go on to the last segment for today's Head Start program. Okay, yeah. Time for me to jump back to my slides. Okay, so I hope that that was informative enough in terms of giving you an idea of what chapters are to come and as well what to look out for in those chapters. Of course, there are a lot more chapters in Set 4, but today we only have 1.5 hours. Come on, right? We just do one chapter each. In the future, if you all like it and there's the demand for it, maybe we can do more of this. I think it's quite fun to just chat with you guys and hear some of your questions and hear you're going to USS. Okay, but these are the main milestones that are coming up your way. You need to know this are coming when. Mid-year exams usually in May, usually in the second or third week of May. They usually test more on Sec 4 topics, but some schools, they still like to recap older stuff. CCA will be super hectic because either your B division, your competition, or your handover, or your investitures and stuff. So you need to be prepared that mid-year is going to be tough. Going back to a point earlier made on consistency, so try to keep afloat, right? In Sec 4, it's very easy to start drowning, especially if you don't learn redox well, electrolysis, GG, it accumulates. So you want to keep your head up from the very start of the year, okay? Prelims will usually be in late August, early September. So normally June holiday is the period whereby you have to heavily prepare for prelims, right? And this is a time whereby doing more prelim papers would really help you perform well and getting used to the entire exam format. So by mid-year, maybe they still don't make you sit for the full paper. It will be a truncated version. But by prelims, most schools usually give you the full length paper, which means the exact hours that you'll be sitting for O-levels eventually. Okay, O-level itself usually starts in the third week of October, usually lasts for 3 to 4 weeks, right? So for science, usually it's in the second week, the MCQ is in the fourth week. Okay, so this one, don't worry about it yet. But mid-October, now is December, you have around 10 months, right? Later my math fail, but whatever, you guys get it. You don't have a lot of time. Okay, that's all I'm trying to say. You are still going to learn new chapters. If you need a gauge, right, when to really truly turn on your engine, right, I would say best is now. Okay, but if you really cannot help it, right, by June, right, June holidays start, you need to start your exam mode already, which means you need to dedicate a certain hours every day. Your core focus would be on the exam itself. With that being said, it's not that you do it without taking care of your mental health and stuff. I think that's super important. Learn to take breaks. But when I say gear up, means your focus should be away from your CCA, away from, not say hanging out with your friends, but can hang out with your friends, but you all maybe study together, right? From June onwards, you have to take things very, very seriously. Okay. For my own students, I already set up the expectations to them that by this time you need to do what already. It has to be a very tight schedule here. And I need you all to know that these key milestones would generally be quite important because by the time you hit prelim, it gives you a sensing of what you'll get by O-level already. At most, realistically, you can expect a 1 to 2 grade improvement. At most, right? Anything more than that, possible, but quite unlikely. So actually, a lot of the battle is either won or lost in June. If June holiday, you really catch up, it can jump from E8 to A2, A1 kind. Real example, I saw my friend do that. For myself, I was failing A math at the start of Sec 4, but I got an A by the time I hit O-level. A lot of the work was done in March. I go back Saturday, remedial, go for tuition and stuff. By the time I hit June, I was doing quite well. By the time I hit prelim, I was getting an A. Yeah, so you kind of need to set your expectations right. Okay, now I wanted to end off with this part on where do you see yourself in 1 year's time, right? So I want you to maybe spend the next 20 seconds to think about what would be L1R5 or L1R4 that would make you happy. So think about it seriously. What is a grade that you think you get, you'll be satisfied with it? Okay, come up with a figure. What would truly make you happy if you get that, right? When you receive your exam results, that's like, okay, my hard work paid off, right? This is it, okay? And I think right now, what you want to consider is how far away are you from that goal, right? So at your current trajectory, are you going to be able to hit that target? Or is it that you're very far away or you're on track? If you're very far away, then what I need you to consider next is that if at your current pace, it's quite unlikely for you to hit that goal, what needs to change? What do you need to do more? What do you need to do less of? Do you need more practices? Do you need to revise your content more? Do you need extra help? Do you need consultations with your teacher? you need to explore those opportunities early and address them early. If you are on your current pace and you're going to hit your target, then my question to you is, how can you make sure that you can keep up your current pace? Is it about scheduling regular study sessions and allocating breaks? Is it about avoiding distractions and stuff? Only you know the answer, right? Your goal might be to go to a certain JC or a certain course in poly. I don't know. But what I'm hoping to share is I hope that you eventually will be able to get to that target. I always say that exams don't determine who your worth as a person, right? You're much more than your exam results. But if there's one thing important about exam results is that it gives you more choice. The choice to choose which JC you want to go to, the choice to choose which poly course you want to enter. Without that score, you have lesser choice. It doesn't diminish you as a human, right? You are still you, right? It doesn't mean your exam results determine your worth. You are still an amazing human being, but now you have lesser choices. And maybe you're left with choices that you don't want. And when you look back, maybe you will have a bit of regret. What if I work a bit harder and I open up my choices more, right? So there's no harm in doing well because now you have more choice. Then what you choose is up to you, right? But if you were not even given that choice in the first place, I think you're depriving yourself of the full potential to pursue whatever interest or to go to a certain school that you think would fit you best. All right. So my goal is that I hope all of you can eventually go to where you want to go to of your choice. That's all. All right. So don't look too hard into the exam. Don't tie your self-esteem with your results, but understand the importance of this next step. All right. By the end of the day, make sure you keep your head up. And I think making sure that you're in a good headspace and avoiding burnout would be one of the most important tasks up ahead. So it's going to be a long year ahead. I don't think it's going to be easy. I don't want to sugarcoat it, but trust me, many batches before you have put through it. Okay, if they can do it, you can do it too. But just keep your head up. Okay, make sure that you're always in a good space. If you have a support group, that will be best. Next year is going to be tough, but it's going to be exciting as well. Okay, now before I move on to the Q&A segment, I just wanted to share the group tuition signups. Honestly, most of my classes are full. Like, I'll be very honest. But if you are keen to sign up, I still have some slots here and there. You can just sign up from the website. You just scan the QR code, right? You see if you want to sit into my lesson. The first lesson that you sit in is a trial lesson. It's for free. If I have a slot available, I'll let you know. You can tell me your preferences and stuff, like which location you want. There's Toa Payoh, Hougang, Yishun, and online. You can come in for one lesson to see if you like the teaching. I'll be teaching, or you can see the format. So if you do join, it's a weekly 2-hour lesson. I usually cover a new topic every week. You'll get a new worksheet. This worksheet is designed according to the latest exam trends, and you get a free copy of the curated notes. But I have to preface by saying that depends on availability. So a bit first come, first serve. A lot of my classes are already full, but if you're keen, maybe there are still some slots left, and those are the classes you can join. Okay, maybe I'll move on to the Q&A segment. Do any of you have any questions? Maybe I can stop recording already.